Tri-tip, can I get like a hand raise? Because I'm trying to figure out how many to follow.
Let's face it, are you showing up? Hands up? Then you're going to want to tri-tip.
Yeah. You don't want to eat some, yeah. Donation. Just the tip? Just tri-tip. All three, yeah. Rich donation, that's all if you want to eat some. So I can actually afford it.
AJLab.com/CAMWA.
I don't know about you guys.
Okay, so if you're still scrambling to get your tamper box in, you have 7 minutes, which is strictly enforced. You'll be fucking qualified if it's turned in at 2:01. Just a reminder, after parties at the 23B shop, shirts for sale outside, et cetera, et cetera. Badge hacking ends at 4 if you have an entry. A lot of good entries so far, so hopefully some more. We have Sam with us, a good friend of Layerone throughout the years. Really great to have him back on a topic that I think is actually pretty cool. I'll just let him go into it. Give him a big round of applause.
All right. Thanks, Datagram. All right. So I'm here to talk about SSD data evaporation, which I heard about 3 years ago in a seminal paper in 2010, and I wanted to see it. And man, when I started messing with it, it is more evil than I ever thought. So I thought I'd tell you about it. Anyway, this is me. I teach at City College, San Francisco. I've been doing that for a long time. And everything you're about to see, the PowerPoint slides and all the references and complete instructions to do everything are on my website, samsclass.info. If you just Google me, you'll find it, plus entertaining blasphemy from people that hate my guts. Anyway, so data remnants. How many people out there know about data remnants? Yeah, not so many hands going up. Well, I'm going to give you a test in a few minutes here. All right. So if you have a magnetic hard drive and you delete something, it's not gone. Ha, ha, ha. That's just there to drive you nuts. It stays around forever until you're right on top of it. So let's see how familiar you people are with data remnants. I'm going to switch from this advanced MacBook Air to a comparatively primitive device using a magnetic hard drive. All right. And, okay, theoretically, we will have video as soon as I figure out which way this connector goes. There, that felt good. Let's see if it actually makes any light appear. Let there be light. Right. Function, and the screen here maybe. Logo P. Aha! Duplicate, that would be cool. Aha! It made a happy sound. Ah, good. Okay, this is a glorious Windows 8 device, which I was completely unable to operate until I went and got the free button that puts the start button back. Oh my God. It's like getting thumbs after your thumbs have been cut off. Anyway, so all right. So what I got here is I've taken a PC with Windows 8 on it, and I've added an SSD, but we're not going to use it right now. We're going to use the hard drive for starters. So I made a little tiny partition on the hard drive, just 200 megs, just so everything will be kind of fast. And I made a file called spam little. This file contains spam, 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 and not very much of it. You have to give it about a kilobyte of spam, or it will put it in an unusual place on the hard drive, which messes up the demo. Anyway, I'm going to put that on there, assuming I can figure out how to operate this machine. There we are. That looks better. All right. So now I have put spam on my hard drive. And you can view it with just a plain hex editor. So here's a glorious free hex editor called HXD, which I use all the time. And you can open the disk and look at the disk raw, the way we used to with Norton Disk Editor and such. Okay, so there's the master file, or master boot record and such. And then we can go find the spam. And there it is, spam, 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 spam. Okay, so this disk is currently full of spam. So let's try step one. I go right up here and I delete that file. Right click, delete. Okay, is that spam gone? No, people say no, all right. Let's try refreshing the view. And you're right, that spam is still there. All I did there was alter contents in the index file, or in the file allocation table, or in this one, the master file table. All right, so let's try going to the hard drive. Right-click, Properties, and go over to Format, Tools. All right, why can't I format this drive? I guess I got a right-click format. Thought it was in there. All right, right-click, Format. There it is. Okay. So I'm going to format that drive. Now this box tells me formatting will erase all data on this disk. So I say, okay. I don't care, just do it, don't gripe. Okay, is that data gone? No. The no's. I hear those no's again. All right, let's try analysis. View, refresh, and yeah, that's right. It has lost its connection to the device, of course, because I formatted it, but I can open it again. And then I can search for the spam again. And it's gone. Now last time I did it with a quick format, it didn't go away. And it was only the slow format that made it go away. But anyway, it stays there until it gets overwritten. Now, I didn't pay enough attention to my demo there. I thought I did a quick format, which should not have erased it. But anyway, let's proceed. This is the old-fashioned world of hard drives. Now, let me just, while I've got this thing going, let me just demonstrate what happens when you do this on an SSD. Now, you have to get the right SSD and the conditions just right. This is a Corsair SSD that I've added in here by removing the hard drive and putting it in. That was a quick format. All right, something's a little out of control about that format. It doesn't give me the same answers every time I do it. However, to have this fun stuff happen with an SSD, you have to have a fairly large amount of data, like a gigabyte. So I made an SSD partition that's a gigabyte, and I formatted it NTFS, and I made a folder full of spam that's a whole gigabyte of spam. And I put that on there, and this is, of course, why you get SSDs, because they're nice and fast, and this is going to copy in just a few seconds, which is very much nicer than a hard drive. And while that's happening, let me go to HXD and mount that disk, and that disk is called SSD NTFS. And I guess there's no reason I can't mount it while it's writing. Doesn't seem to be. If I do Control F, I can find the spam, and there's the spam. And lots of this disk are all full of spam right now. So, as soon as this is done writing to it, all right, now it's done writing. Let's put the hex viewer on the left and put this thing on the right. Okay, I'm going to right-click and delete. And it's going to tell me it's too big to recycle, permanently delete it, and I'll say yes. So is that data gone? View, refresh. Now F5 will do the same thing. It's too hard to figure out the buttons. View, refresh. You say that data is not gone. Is that what you people tell me? 11. Yes, it is. It takes about 14 seconds, and then it's gone. Now, this may seem like a small matter, but this is a really big matter for people in data recovery or computer forensics. So let me go back to my slides, and let's play some games here. All right. That ought to do it. And I might have to pull this out and put it back in. Nope, good. All right. So I showed you that. All right. So now, since data does not vanish, normally when you delete it, there's this whole science and whole game of recovering deleted data, which we all do a lot of, and there are companies that do it and such. And of course, this is why you catch criminals all the time, because criminals will do something bad, and then they will do something foolish, like drag it in the recycle bin and think it's gone. And so you can look and find all this great evidence on the drive. So we've gotten accustomed to this high-quality situation in computer forensics where we expect to make an image of a hard drive and get all the data, the old data and the new data, and we expect to be able to make many copies of that and have exactly the same file with the same MD5 hash. Computer forensics is repeatable. It has been a luxury we have enjoyed in computer forensics for a while, and the game is over. Anyway, if you want to recover your data, these are fun tools, Recuva for the PC and Disk Drill for the Mac, that will totally bring back your deleted files, as long as you're storing them on magnetic disks. And there are companies like this that will bring back your data even if your drive fails and rebuild it, and they'll make a lot of money doing that. I must say, we went and toured this company, and the people there are very happy. They really like their work and they're very advanced. They get a lot of company lets them go out and learn all the new stuff about every new storage device, including SSDs. So let's talk about SSDs. SSDs are not a small matter. In this chart, the SSDs are the pale blue, which is a small fraction of the market around now, but it's growing and growing until it's going to be 40% of the hard drive market soon. So it's not, hard drives are not going away. They're going to remain the cheapest way to store a lot of data, but SSDs are going to be more and more popular, and not only for being faster, but for using less power. So we're going to have a lot of them, but there's a fundamental difference between hard drives and SSDs. In hard drives, you read and write data, typically 4 kilobytes at a time, and if you want to clean a sector, you just write right on top of it with no problem. SSDs must be erased before you can write on top of them, and unfortunately, you cannot erase one page. You have to erase one block, which is 128 pages. And you can't just go on erasing blocks all the bloody time because you can only go through a certain number of erase cycles before the SSD is used up. The number I've seen quoted is 10,000 cycles. Other people have said it's more, but it is enough that people worry about this quite a bit. And therefore, if you think about something like a log file that keeps on adding a couple lines and saving it, adding a couple lines and saving it, that's a lot of rewrites to the same file, and every time you do that, it would have to erase 128 blocks. So that would really wear out your SSD. So they don't do that. What they do is if you buy 320 gigabyte SSD, they give you 10 or 20% more storage than you paid for, don't tell you, and the controller silently swaps out those empty blocks when necessary, so that even when the drive appears to be 99% full to you, it is not full, and it's easy for them to find whole pages, whole blocks to use that haven't been used yet. So it only erases them when it really has to. So if you store a small file, and then you add a few lines to it and store it again, it puts it in a completely different block and marks that other block, and it won't erase that block until it really has to. This is called wear leveling, and it has a lot of very disturbing effects. One of them is that if you try to write to a specific block, like block 100 on your SSD, your computer will send the command, put this data in block 100, and when your computer goes back later to read what's in block 100, it'll find it, but it never went in block 100. It went in block 10,030, and there's an internal table inside the SSD firmware that knows that, the computer does not know that. So if you want to make a forensic image of an SSD, you tell it, I want to get every block from the first block to the last block. That's not what you're reading. You're reading some random portrayal of blocks, which may or may not include those blocks at all. And if you want to erase an SSD by writing on top of it, you can write zeros to every block from the first block to the last block, and you did not get them all. And you don't even know which ones you got. So that's clean fun. And if that's not enough fun, the data is changing while the SSD is plugged in without you doing anything. In forensics, we use this thing called a hardware write blocker to make sure you don't alter the drive while you're reading it, but the SSD alters even without you reading it, just from the power being on, because of garbage collection. Now, normally a hard drive and an SSD does not even know when you delete a file. You just make a mark in the file table, but the drive itself doesn't know about your file table and does not know those sectors are no longer in use. But SSDs could really benefit from knowing that because they really have to control this erase process. In the first place, it's slow. In the second place, it wears out the drive. So the controller wants to know when things are to be erased and not to erase them just before you write, which would make things slow, but to carefully plan when to erase them. This is called garbage collection. So if you support the trim command in your operating system and the firmware and the SSD, then the SSD is told every time a file is erased, and then it can put it in the queue to be cleaned up with this garbage collection. So this has been called self-corrosion. I find it better to call it data evaporation because it reminds me of RAM. RAM is volatile, like a liquid that's volatile, which means if you store data in RAM, when the power goes off, it vanishes. And if you store data on an SSD, when you delete it, it will spontaneously vanish under the right conditions. So anyway, all right. Actually, I'm a little bit early, so I think I can probably show you this one. Here's the more fun demo. If you go on the Mac, you can, let me go to my desktop. Okay, I've got a folder here. Spam orig. Okay, this is another folder all full of files called spam. Now I'm just going to make a copy of that folder right down here, and see there it goes in about 5 seconds making a copy of that folder which contains a gigabyte of spam, just like the one I was throwing on the last one. Now the MacBook Air uses nothing but SSDs. So I've now created a folder here which has 5 files, each 210 megabytes in size, full of the word spam. Now, I'm going to run a data recovery tool called disk drill, which I thought I put down here where I could find it, but if I didn't, I'm just going to go here and find it. Disk drill. Okay. There's glorious disk drill. I'm going to use the free version. Okay. Expand this, and you see, here's my entire Macintosh hard drive, almost 500 gigs of glorious data. So I'm going to go in here. I'm going to delete those files. Shift, delete. Drag them into the trash, pardon me. This is a Mac. All right. Drag them in the trash. Now they're no longer in that folder. Now I'm going to empty the trash, which I think is not really necessary, but it's sort of pretty. All right. Yeah, it's necessary if you do it in the GUI like this. Okay, now I've deleted those files. Now let's try recovering them. This is Macintosh HD. I'm going to do a quick scan, which takes about 40 seconds. And we'll see what happens here. And let's remember this number. It's 208. Maybe you'll be able to remember that. Doesn't really matter here. All right, no files found yet. Now it's scanning the entire disk structure. This, by the way, is scanning the entire 500 gigabyte hard drive, which is another reason why you get SSDs. They rock. This is very fast. Less than 1 minute to go through the whole 500 gigs and recover all the deleted files. Anyway, it's being too slow for me, so let me let that go in the background while you proceed here. Up, I think it just saw it speed up. Yep, okay. There, it's done. Switch users, SAM, desktop, spam, and there's 4 of those 5 files. One of them has already vanished forever, which is interesting. And when you do this a few times, here's the result of me doing this 5 times a couple days ago at Starbucks in minutes. Some of the files sometimes vanish quickly, but most of them are gone after 30 minutes, and they never take longer than 60 minutes before all 5 files are gone. So the time it takes for those files to vanish is random, unpredictable, and can be up to an hour if you put them in a folder on your desktop on the Mac. As we will see, under other conditions, it can take different amounts of time. So a Corsair in a PC took 12 or 15 seconds. On the Mac, it takes a random time, 30 minutes to an hour, and I have not found any pattern. I don't know if it's got a clock and it's waiting for the top of the hour every hour, time to clean up the garbage, or what it's doing. It's very odd. All right, so we watched the data evaporate on the PC. You already saw this. Now, you can turn trim off in a PC if you want to. With this fsutil command in Windows 7, you can turn it on and off. It's on by default, however. So here's what it takes for that trim command to work. You have to run your drive has to be SATA, and it has to be running in SATA mode, not IDE emulation mode. If it is in IDE emulation mode, it cannot understand the trim command, and it will not know when files are deleted, and therefore they will not evaporate. You got to have a relatively new Intel, the newest generation of SSDs. Older generations didn't have this. You got to run a new operating system, Windows 7 or Mac 10.6. And if you run it on the Mac, you have to use Apple-branded SSDs. Trim is not supported for other types of SSDs, although there are some hacks that work partially in some versions of the Mac, but they're not very reliable, and Apple keeps fighting back. It's sort of like jailbreaking an iPad. You're trying to defeat Apple's plans here. And if you use an external drive that's USB, no trim. If you use an external SATA or SCSI drive, it can in principle support the trim. PCI Express and RAID, again, no trim. So whether data evaporates or not is kind of goofy. Now, the reason why I thought this is really important, the thing that motivated me, I was teaching a forensics course, and I've been through something, several of my forensics courses and my forensics teachers have taught me about this, expert witnesses, right? Forensic scientists are expert witnesses. We are not like other witnesses in court. Other witnesses have to talk about what they saw. They say, I saw this guy shoot somebody, and that's the guy. But if they want to talk about it, well, do you think he was angry? They say, I'm not a psychologist, I can't have an opinion. Because you can't have an opinion in court, just the facts. But an expert can have opinions. But opinions must be based on experience. So if the expert witness wants to have an opinion, and they say, oh, I know that's true because I read it in a book. That's not acceptable. A teacher told me that's also not acceptable. It has to be based on real experience. So you have to do a lot of testing in forensics. You have to be able to say, I know it's true because I tested it, and that's why it works. You can't trust anybody else. It won't hold up in court. So you got to be able to test things. So That's the problem here. If you want to know whether data is evaporating, good bloody luck. It depends on everything. It basically depends on the hardware, the operating system, the BIOS, and the firmware in that drive, and it's not documented by the manufacturer typically. So really, if you want to know, you're going to have to use the real drive or one of the exact same model and run some tests on it in the short run here to find out whether it really evaporated under your conditions. But I do know this has already affected some forensic scientists. I've heard people talk to me about how they image a drive and they calculate the MD5 hash and then they image it again and get a different answer. And this is very bad. This is not what you want. You want to be able to get the same thing holding still. That's what we've gotten used to. And with SSDs, you often don't. And it's pretty obvious that this is one part of the reason why. So I wrote a tool here to play with for Mac OS X. The tool is probably more useful for serious work, but it's a little less dramatic than these nice graphic things where you can watch the thing in the hex editor and stuff. So I wrote this tool and I wrote instructions. Let me just run this thing. It's a text-only tool, but I'll just point out all this thing does is first you have to make a 1 GB partition labeled SSD, and then you unzip this tool and run it in the command line, and then you can easily write to an SSD and watch the data evaporate to see if it does. So let me just run this thing up here. I put it in a folder called E. I run it with sudo evap1. I'll make that bigger. All right. ./evap1. That looks big enough to read. Can you see it back there? Okay, fair enough. All right, so I run this thing. Give it a password. Okay. There's what you have to do before you get it working, and then here's the options. So what I'm going to do is I'm going to prepare, I'm going to use E to erase my volume and format it with the very newest Mac file system, which is journaling HFS+. That's the latest and greatest, and then I'm going to write some test files on that volume. The test files are just a bunch of files like my spam file, only have 1 letter each. One's all full of A's, one's all full of B's, one's all full of C's, and there's a few other characters. So if I scan the drive, this is going to use DD to just grab about 80 random characters, not random, but evenly spaced across that drive. It's going to give me a sample of the whole gigabyte of data that I can see. And that's what it is. It's got these characters, then it's got A, B, C, D, E. This is just grabbing 80 or 100 characters in a pattern across the whole drive so I can see how much data is on there. And I filled the whole thing up with text files. Now I'm going to delete those files, D. This will just use the command line delete to delete them, and then scan them again, and they're gone. Except it's left a few, Q and W here. Now this is a fact about what happens when you make another partition on the Mac, and you scan a partition that does not contain the operating system as well. The deleting happens instantaneously, so fast I can't measure the time, within about 1 or 2 seconds, and it is not complete. It doesn't get it all. This, by the way, is not very surprising if you think about it, because it's got those groups of 128 pages, and it's going to erase a whole group, and there's probably a few of those files that were just partly filling something, and it decided not to erase it now but wait till later, because it might still have later some fragments of a file to put in there. It might not be the most wise time to erase all of it. So it's not too surprising it's not complete. But what's other good clean fun is if you go and I think it is F. If I use F, it'll now reformat that volume, erase it, and make it HFS+ that's not journaling, which is a perfectly fine format, but it's just not the latest Mac format. Now if you write those files, and then you scan them, and then you delete them, and then you scan them, they're still there. They aren't going anywhere. You can wait as long as you like. It's just like a hard drive now, because you didn't use the very latest file system. And I could show you on the PC, I think I won't bother because it seems like you got the point. If you take the PC's SSD and format it FAT32, the same thing happens. It will never evaporate. So it depends. If you want to say, well, that data vanished, you can't count on it to vanish, and you can't count on it to stay still. And when it vanishes, you can't count on it all to vanish. And so basically, life just got a little bit more complicated. Of course, the first paper published about this stuff said this may be the end of computer forensics. And I don't think that's fair. I think, in my opinion, not that I'm a lawyer or anything, I'm not even an expert witness, I just teach about it, but I took classes from guys that were. In my opinion, this does not ruin computer forensics. This just demotes computer forensics from this mathematical science where they had this thing called a perfect image of the disk down to every other kind of forensics. Like you got a blood stain or a fingerprint. You can analyze that fingerprint once. You cannot bring another person in and analyze the fingerprint from zero and get exactly the same answer. Tough. And you can't do that with SSDs either. So We just have to be like everyone else. You can measure something, you can go to testify in court and say, I did a good job measuring it, and here's the answer, but it is not true that someone can start from zero with the original data and completely duplicate my work. Anyway, all right. So that's the main thing I came here to tell you, but I thought I'd have a little more time, which I do. So anybody got any questions about this data evaporation or anything? Yeah?
You said this depends on trim, or?
Trim, yes. If you want to delete files and see them vanish, it must have trim or the drive won't know. Otherwise, it'll only delete them when you format the drive. Yeah?
You said you've seen some inconsistencies with non-Apple drives. So for example, using trim enabler, are
Yeah.
the inconsistencies here or just with it functioning?
The only thing I know is it's functioning.
Okay.
Because I put some options in this tool to turn trim on and off, and they only work for older versions of Mac. On new versions, they work about half the time. That's the point. There's a bunch of trim enablers too, and I don't know how well they work. It'd be fun to get one of those and then run this tool and see. I don't have one. All I have is a built-in Mac one. But that's a good point. But I do know the tool worked on my older Mac, and when I got a newer Mac with the latest version of OS 10, the tool no longer worked. So I think Mac is kicking back. Apple keeps altering their system. Yeah?
How does this work with like flash drives and SD cards?
How does what? SD cards?
SD cards and
Uh,
flash drives?
That's a very good question, and I do not know the answer. Now, I tried USB sticks, and there was no evaporation, but then I found out USB doesn't support trim, so that's not surprising. If you could mount an SD card internally so it goes through SATA, I would think the same thing would happen, but you would have to try it and see it. I bet it depends on the model, and that's a very good point. That's why we need a lot more people testing this stuff. I've only done it on a couple of systems, and there are hundreds. By the way, I had to buy 3 SSDs for the PC before I got one that would work. The others, even with the most modern operating system and every BIOS setting just right, did not ever have the data evaporate. By the way, another thing, this is supposed to make your SSD faster, but I've tried it, and measuring the time it takes to write and clean, I can't find any difference. So I probably need a more subtle performance measurement to see what the benefit is of this trim anyway. Making it last longer, I can kind of believe, but making it faster, I'm not so sure. Anything else? Because I got a totally different topic to show you, which is probably even more important and very exciting. All right. I gave a talk here 2 years ago about denial of service attacks, and after that, a black hat hacker contacted me on Twitter and said, that's a pretty good talk, but you didn't cover SockStress, and what are you using Backtrack Linux for? What are you, a wimp? And I said, well, I guess I am. What should I be using? He said, you got to use Slackware, or you're nowhere. He said, and why do I have to use Slackware? Because I got to use SockStress. And I said, SockStress? Now, this is an old attack from 2008. I heard about this thing. You all heard about this. You hit a podcast. Every TCP using device on the internet is going to be destroyed. This is the end of the world. But somehow nothing ever came of it. I heard about it too. I tried to find some code. All I could find was some code that didn't work. And I played around with it for a while. Nothing ever happened, and I just forgot about it. Microsoft patched something related to this, and I thought that was the end of it. And this guy said, no, I used it to take down a server last week that irritated me. Put up a picture of my girlfriend. I nuked that server bad with SockStress. And he said, with this tool, you can kill something and it won't even come back up. You can destroy servers completely with this thing, supposedly. So I said, well, this all sounds like nonsense to me. But I looked into it, and what happened is it was developed in 2008, and there were some podcasts talking about it, and then the developer died. So he never got a chance to go to the security cons and run a dog and pony show like I'm about to, and explain to us all how awesome it is and get people to care, and so nobody cared, and so nobody fixed it. And it still works today, 5 years old. So let me show you SockStress in all its glory. By the way, the idea behind SockStress is incredibly simple. If you do a synac, you can send the ACK with a small window size, like 0 or 4 bytes. And what that means is, hey, I want to make a connection. Wait, I'm busy. Hold on, I'll get back to you later. But I am going to download that file, really I am. And this will hang up the server waiting for the rest of that connection. And it turns out that you can do a lot of damage, and I got it working pretty well. You'd have to run it in Slackware. So let me get my stuff. This one works pretty well in virtual machines. So here's my Slackware. And for a target, I'm going to use this Windows 7 machine with 2 gigabytes of RAM. All right. And I know this is currently used by black hats to take down real servers, and it affects basically anything that uses TCP. He's not joking. This is not a bug. This is not a zero-day flaw you can fix. This is in the design of TCP. However, as usual, it's in the implementation that the suffering comes up. So let's get Task Manager running here so you can see how burdened my Windows 7 target is. So you see here, the CPU is down to 0%. The memory being used is about half of a gig, and I got 1.5 gigs just sitting there empty. So this server is not heavily burdened at all right now. Now, in order for this thing to run in Slackware, you have to do two things. Let me just show you this. You have to attack many open ports on the server, and you have to attack them from many sources. Now, you could go get a botnet or something, but you don't even have to. You can fake a botnet. You can send packets that come from multiple local source addresses, and you can get them from DHCP as long as you have something that will answer fake DHCP replies. Now, the original designer of the tool wrote a tool to do that, and I could not make it work, so I wrote my own, which is not hard at all. It's just escapee script. It's artpoi, so I do just do cat artpoi 2 is the one I'm using. I made it even simpler a couple days ago. There it is. I don't know if I make this bigger. Shift Control Plus. No, okay, not in Slackware. Anyway, it's just a few lines here, and it's on my page. All this does is listen for ARP requests and give you an ARP reply. Always giving it the same MAC address. So my machine can have many MAC addresses. This is really important because you have to attack from many IP addresses, and if you attack from the main IP address that the machine is really using, you will kill the attacker too. The attacker is not protected in any way from this attack. The attacker is using TCP. So you can kill your attacker while you're killing the target if you don't do it this way. So what you do is you have a real IP address that you're using for communications, and then you have a whole /25, 128 fake IP addresses, which you're sending packets out from there, but you're not actually letting the operating system know that you're making TCP connections there, so it does not burden the Slackware operating system with maintaining those half-open connections. Anyway, let me run this thing. It's start ARP. Okay, now I've got the fake ARP thing running. Now I'm going to start the attack, and this should be good, clean fun. Sock. I made a script called Sock that starts the attack. All right, there you are. So now it's sending 2,000 connections per second. The CPU is up to 100%. The RAM use is increasing. And if you look at the ARP, it should be showing a bunch of resolutions there, but maybe it's already remembering them from before because I suspended this machine right after a long attack. Anyway, this is doing just what it should. So on the right is the attacker sending 3,000 or 4,000 connections per second from 128 source ports to about 10 destination ports. I got about 10 listening services on that machine, FTP and Telnet and a web page and all that jazz. And all right, I guess nothing important died there. So now we're up to 900 megs, and you can see in this handy little graph as the RAM is just going up and up and up. And this may not be exciting enough. We may just let this go for a while and come back to it. But the interesting thing, I'll just tell you the punchline is, you can run that RAM as high as you want until the machine crashes and dies, and when you stop the attack, the RAM never comes back. It's permanently in use. It's an implementation error. It is waiting for, it's storing something in RAM that it's ready to deliver to the other machine, and it's waiting, and the window size is 0 or 4, so it can't actually send it. And it's just filling that all up in RAM, and when you drop the connection, it never comes back. So this is something that could be patched on that side. Anyway, I was not able to break this machine to where it wouldn't even boot, but I am able to freeze it so nothing works on this end. When it starts running out of RAM, it's just going to go crazy. It's kind of good, clean fun. I'm going to leave it go in the background, may come back to it. But it's kind of fun when it gets all the way up. Let me just wait. We're already up to 1.2. Thought it'd go pretty fast. When it gets to the top, you can watch the server die. It starts squirming around like a worm on a hook. Yeah?
While we're waiting for this,
Yeah.
have you ever tested this against, say, a VMware ESX box with multiple hosts?
No, that would be very nice. You want to test it against an ESX box with multiple hosts? I didn't, but of course, the real black hat that convinced me to do this is doing that all the time.
That could be really interesting.
It takes down everything, according to him, and as far as I can tell, he's right, because I made nothing special. Now, when I first tried it, I was having lots of trouble with the Slackware and everything, and I made a special weak host that only had 512 megs of RAM. But yesterday, it worked so well. I said, what would happen if I made a real host with 2 gigs? And man, it works just fine. As far as I can tell, it doesn't matter how much resources you have at this end. It's just using them up. and it's going to die a gruesome death. It's kind of fun to watch it croak and die up there, although I wasn't able to render my virtual machine unbootable. But what he tells me is this attack is not for wimps. You have to take over a server to do this attack, and a real server running something sensible like Slackware, and then you have to really send some powerful bunch of connections from it, and then he says you can kill machines so they can't boot up again. Now, what I assume is going on there, I'm just guessing, is you're freezing the machine so badly that it needs a hard power off and a hard power on, and that will often make servers unbootable. That's all I'm thinking. I can't imagine it could do anything more than that. But anyway, we're nearly up to the part where the server will start being fun to watch here. 1.7 gigs. In fact, it's already stopped updating Task Manager, I believe. It looks to me like Task Manager has frozen here. And if I can no longer use the mouse. Yeah, we've got a reasonably dead server here. There, it's responded a little bit to me that time. Now it's updating a little more, but notice how the nice smooth progress is beginning to fall apart here. And yeah, now it's going to start going up and down. The RAM and the CPU will both start going up and down until they go crazy on you. This could be your server. It's a gruesome thought. And nobody's patched this in 5 years, so I thought it might be fun to take this to the cons and engage in the usual humiliation ritual of irritating all the vendors until somebody actually cares enough to fix it. And this is, I think, why nobody fixed it and why I didn't even know about it, because it's not that easy an attack to do. But I wrote up complete instructions a few months ago. Anyway, this thing, we'll come back and look at it. It's going to wave up and down and do entertaining stuff. So, I got one other thing to show you, because there's still time, which is what I thought would happen. I got another old attack. But anyway, here's some pictures from before. Let me make this big. So there it is, gradually using up. Oh, yes, yes. Okay. So there it is, climbing to the sky. And when it's done, it starts freaking out on you. And I turned off the attack here, which causes the CPU to go to 0, but the RAM use just stays high forever, which is not healthy. The only thing that's going to fix this server is a restart. And all right, so now, I'm always talking about IPv6 because IPv6, by the way, is more of the same. You know, IPv6 came out in 1993, and the plan was to have 100% deployment by 1999, and none of that happened, as you might have noticed. Yeah. Yeah, that's good. That's why I have this terse statement here. No, 6 is greater than 4, man. There's only one. Anyway, so so IPv6 came out, but instead of being fully implemented by 1999, it's not even implemented yet. And all the stuff we're using is junk, pretty much. I don't hope the guys in Microsoft don't hit me too many times with a hammer, because they worked real hard to put IPv6 in Microsoft products. But everything we have is just thrown together hastily and not tested, and it doesn't work. And it's kind of fun to blow it away with every tool you want to try on it. And so security is a big problem. Anyway, this is why we have to do it. We're running out of IP version 4 addresses. The main reservoir ran out a year or two ago, and North America is expected to run out of addresses next year. So there's going to be no more IPv4 addresses available at all. You can use the existing ones, but you can't get any more. So IPv6 has a few more addresses, so I made an IPv6 exhaustion counter. This is the projected date when we'll run out. So upgrading to IPv6 will give us a little more breathing room here. So this is the old link local DoS, the thing I showed you 2 years ago. And this is the old-fashioned attack. Now the way this works is when you get an address in IPv6, you don't usually do it with DHCP, although you can. This is not the most common. DHCP is a pull process. The client boots up, it says I need an IP, the router tells the IP, that's the end of the transaction. That will not happen anymore until the client boots up again, or until days pass. But in IPv6, it doesn't work that way. The router just sends out periodic router advertisements, and it tells everybody that can hear it, you have to stop what you're doing and join my network. Create an address and join my network. This just goes out, it's pushed out from the router, and this goes out as a broadcast packet, although technically there is no broadcast in IPv6. There is instead something called multicast to all nodes, which is essentially the same thing. So the router advertisement packet goes out, you can pick it up in Wireshark, and the router advertisement packet goes out to this FF02::1, which is the broadcast to all nodes address, and it contains a prefix, 2001 and all this hogwash, and therefore everybody that gets that packet has to join that network. And if you send out a flood of broadcast packets with random prefixes, then the machine has to create all these addresses, and that doesn't seem like a big problem, but unfortunately, it's quite efficient at killing Windows, because Windows, and for some reason BSD Unix, are incredibly inefficient at creating these addresses. They can only create about 5 of these per second, and that uses 100% of the CPU. Don't ask me why. I can't imagine. It's got gigahertz processor. All it has to do is make one address. How hard can it be? Apparently, it can be very hard. Apparently, it can take 200 milliseconds at full CPU. So if you drive this thing in 2011 against Windows machines, it'll push the processor up to 100%, and it'll stay up there just like that SockStress is doing. The CPU will be at 100% forever. You'll have a backlog of 4 hours before it ever comes back. So Microsoft patched it, sort of, about halfway in November of 2012 with a thing called the IPv6 Readiness Update. But the IPv6 Readiness Update is only available for Windows 7 and Server 2008 R2. For some reason, Microsoft did not patch their newest products, Windows 8 and Server 2012. Probably because they feel like it's not vulnerable. And the man that wrote these attack tools also feels like it's not vulnerable until about 3 weeks ago when I managed to talk to him. But I started playing with this stuff. I got a student who's an IPv6 fanatic, and he and I worked forever on this stuff. We got a lab set up. So we had a real IPv6 lab, really going to the internet on IPv6, and then we tried this tool. There's a new RA flood, just came out a couple months ago. And all this does is use more devastating router advertisements. It turns out, I don't know why you would do this, but you can advertise multiple routers and multiple routing table entries in the same routing advertisement. So now every single routing advertisement packet contains 17 route entries and 18 prefixes. Looks like this, goes on and on. So each one of these is like 25 or 35 of the previous ones. Then you send a flood of these out as fast as you can, and it has no great effect. And what happened is I brought my machines down. It was real dramatic. The next time I tried it, it didn't work. Then I tried to work again. I was trying to make a video, and I couldn't make it hold still. And I said, what's going on? And my student said, it only works when there's a real router in the network. And I said, that's stupid. Look, a real router puts out one router advertisement every 5 minutes. I'm putting out 1,000 per second. There is no way that one more makes a difference. You're wrong. It's got to be the cable. It's got to be the switch. It's got to be some adjustment. He was right. You have to have a real router in the network. So let me show you this one. This one's good, clean fun. Well, let's take a look and see how this thing's doing. Yeah, there it is. This CPU came down to 0 finally. I don't think the attack has stopped. Anyway, I'm going to have to stop this one. Whoa, looks like my attacker's not healthy. All right, anyway, rather than worry anymore about that one, let me set up the new one. And by the way, there's a fun thing to show you, and I'm glad I have a few more minutes here, because you guys are vulnerable out there. Now, in this con, unlike every other, all of you aren't sitting there on laptops, which is kind of a shame because you could be victims without knowing it. However, somebody in that hotel is a victim. I'm not going to bring them down, but I'm going to tag them. All right, let me connect to the hotel network. Right here, the one that worked before was ATT Wi-Fi, which I think is Starbucks, although when I had to approve, you saw me approve it on the other machine, and it seems like I had to approve myself for the hotel. You can join if you like, join this network and see what happens. All right, I'm on the ATT Wi-Fi network. Now, I'm going to send out some routing advertisements from here. Now, I'm going to send out CC5F, college I teach at. Then dude, okay, that'll do. Some kind of distinctive string here. I'm sending out a network starting with those letters. And to detect it, I'm going to run this tool called Passive Discovery, which, see, when a computer does create an IPv6 address and join the network, it has to make sure it's not already in use, the address it created. So it has to send a neighbor discovery message out saying, hey, man, I'm about to use this address. Is somebody already using it? So I just listen for those. So if anybody actually cares that I'm sending out router advertisements, they will pick it up here, and to pick up only the ones I created here, I'm going to get the ones with CC5F in them. I guess I'll put in dude 2. Okay, so this will show me if there are any CCSF dudes around here. I got to put in the right password. All right, so now I'm going to send them out, and didn't like it. Oh, I forgot, I'm missing a colon. Okay. There, now it liked. Okay, there's a couple people on my network. Now I'm going to put this Windows 8 machine on. Might already be on. All right. All right, the Windows 8 machine is on. If anybody else joins, you'll eventually join here. Before I had about 10 people that are victims here. I'm not going to pursue it. It depends on how many people happen to be joined to this network that are running machines that are running IPv6, but almost every modern operating system does. So anyway, I'm not going to kill everybody on that network, but I am going to kill this machine here. So just a second, I've got to run this thing through a projector. All right. This thing over here. Yes. There we go. All right. I think that's going to come up. All right. I'm going to get rid of the wireless. Okay. Oh, good, it's coming up. All right, theoretically, we'll have a Windows 8 desktop here in a minute. There we are. Okay, there's my Windows 8 desktop. It's all crooked and everything, and none of that matters because it's not a very subtle attack I'm using here. So, let me bring up. Okay, so right now I have no networking at all. Now, this is important because this attack, sort of like SockStress, kills everything in the world, including the Mac. So in order for my Mac, I used to need a lot more computers to do this because I couldn't use any virtual machines because it'll kill the host underneath the virtual machine, which is not the point. But then I got a USB NIC. This is a trick I learned from Jeff Carell, who is a really interesting guy. He came to my class to show some IPv6 attacks. And he brought a whole bunch of USB NICs because if you have USB NICs in virtual machines, you get this box. And I can now say connect to Linux. And then what happens is it's a virtual machine, and the virtual machine can send packets out, but they're interpreted by the host as USB traffic, and they don't kill the host. So this is actually very nice. So now my virtual machine has another NIC that the host does not know about. I'll put it down here so we can see the results. It's now got a thing called ETH1. Now, this is just a cable connecting two computers together. There's no router or nothing. So there's no IP version 4 addresses, but I don't care because this is an IP version 6 attack. So they're connected to each other. And if I do that fake router again, I'm going to send out ABC dude. And when I do, I should see it on this Windows 8 machine. Oh, pardon me, I sent it out the wrong address. I'm sending it out the wireless network. I want to send it out the wired network to ETH1. There we are. Okay, this is the kiss of death. I sent out router advertisements from that Linux machine. This Windows 8 machine got them, and it auto-configured. You should see right there, addresses starting ABC dude. That means this machine is auto-configuring in response to router addresses. And the trick to this attack is you must first have a normal router in the network. And I realized you can simulate that. That's what this is. This sends out one router advertisement per second of just plain ordinary RAs telling you to join a network. You must do that first, or Windows 8 and Windows Server 2012 are not vulnerable. This is the thing that the designer of this tool did not know, and only my student figured it out and convinced me. This is why I've been able to demonstrate this. So now I can run that lethal flood, which is flood router 26 ETH1, and that's all it takes. Now it's going to send out a lot of packets. I thought I might do an IP config, but if I let this thing run, it's still frozen. It won't be able to do it. Anyway, this will take about 20 or 30 seconds before we see the result on glorious Windows 8. $17, $18, $19, $20. Yes, taking a bit longer than I thought it would. I see my mouse move? Ah, there we go. The blue screen of death. That's what you get. Sometimes the projector catches it and sometimes it doesn't. And the same thing happens to Windows Server 2012, and the same thing happens to the Apple. And the same thing happens, the previous attack, BSD Unix was vulnerable, and I submitted a bug report and it was just ignored. So I imagine it's still vulnerable too, although I'm not sure. Anyway, this is my next effort to try to get Microsoft to patch this. However, some people might not worry about this because this is a layer 2 attack. You have to be on the same layer 2 network. You cannot be trapped. Now, SockStress can attack you over the internet using TCP. It's a layer 4 attack. This can only attack you from within your local network. But one person running this can kill every machine in a network. That's why I think it's serious. And another reason why it's serious is everyone's going to the cloud. So people are taking their physical servers and putting them up on Amazon E2C or Microsoft Azure or one of those cloud services. And what you're typically getting there is you're getting a bunch of machines that are all in the same layer 2 network. Now I rent a cheap server from RapidZen. It's a virtual machine. It gives me, at least it used to give me IPv6 native. They took that away, which is kind of rude. But anyway, it's a virtual machine, and I ran a test, like the one I just showed you, to see who else was on my layer 2, and I found 180 other customers on the same layer 2 LAN with me. And I could kill them all, and any one of them could kill me. And this is what people told me. They say if you rent a real server in a server farm, they just put you in a rack and a switch with everybody else, and they say it's your problem. And if you rent a virtual server, they just do the same thing virtually. They put you all on a virtual switch. So actually, attacks that kill everybody in the same layer 2 are not as harmless as one might imagine. Turn that off so it's not annoying. Anyway, all right. So let me go back to my slides and see if I got any more to say about this. See, this is the trick which I'm trying to make sure everybody knows about. How to make this attack work, you have to first send some normal router advertisements so that it actually automatically configures a normal address. That creates the vulnerable condition, which makes me think that Microsoft must, I'm just guessing, Microsoft appears to have put a defense mechanism in place, because one thing is true, before the patch, Windows 7 would just configure thousands of these addresses. After that, it only configures 100. They say there's an official limit. We'll never configure more than 100 automatic addresses. And that's true. It only configures 100, but it continues to suffer and die. So they didn't actually block the process that's the problem, but they blocked the result. Anyway, but apparently they put in some kind of safety switch that notices when you're under a flood, but it only works if you aren't actually in a network that's using that process. Anyway, so hopefully Microsoft will fix it. That's how you perform this attack. First you send out a fake router or two, and then you send out a flood, and that's it. Then Windows dies a gruesome death. And by the way, it kills the Windows 8 tablet, the Surface RT over wireless. It kills Android phones over wireless. It pretty much kills everything I've been able to test it on. I'm happy if more people want to test it, and this is the problem. By the way, this kind of attack is pretty annoying because it doesn't work on all switches. It kills some of my NICs I used it with, and my USB NICs can't handle it, and some of the switches I put it through can't handle it. The problem is like a flamethrower. You kill all the devices on your network. You have to get devices that are strong enough to withstand the attack enough to deliver it to the one you want to kill. So it takes a little playing around. So here's the list of what I did. Windows 8 Server 2012 die and Surface RT dies. Mac OS 10 freezes. It doesn't give you the blue screen of death. It gives you the spinning circle of death. You can't do anything. You just have to do an abnormal power down. And you have to do 2 restarts to get it back to normal. Kills the iPad and the iPad mini. Kills the Android phone sometimes. Ubuntu Linux and Kali Linux, Debian-based Linux doesn't care at all. Sails right on as if nothing is happening. And I like to hold that up as the example. I was going to bring one in and do it, but I didn't bring it. Had enough junk here. I want to tell Apple and Microsoft and everybody else, look, it can be done. You can make an operating system that just shrugs this off like it's not happening. Ubuntu Linux does it. It's open source, for crying out loud. Why don't you guys steal the code? Anyway. They don't have to settle for this lame stuff. The patch, by the way, for Windows 7 and Server 2008 has the effect that the thing freezes completely during the flood. The mouse won't move, nothing will work, but after the flood stops, it recovers. Now, I don't think that's a very good patch, but it's better than the blue screen of death, better than freezing for hours afterwards, what it used to do. I've written a lot of videos about these things and a lot of descriptions about how to do these attacks on my website. So, protection. You can turn off IPv6 entirely. That will protect you, but this is going retro. I mean, the world needs IPv6 and more services rely on it. You could turn off router discovery, which means that your machine will no longer automatically configure these addresses. That is probably the best solution, in my opinion, for a server, because you don't want your servers automatically configure addresses anyway. You want to put manual addresses on your servers. So for clients, though, you probably do want these automatic addresses for the same reason you want DHCP, so people can easily connect to your network. So then you can use tricks. You can use a firewall. For example, the Windows firewall built in can block rogue router advertisements. You just say, don't accept any router advertisements that don't come from the official approved address of my real router. Now that, by the way, is easily bypassed because you can spoof the from address. This is not TCP traffic. This is broadcast unicast traffic, so you can put any fake from address you want in it, but still that's an obstacle of some sort. You can get RA guard. Cisco is real proud of their RA guard, their proprietary solution to this. You specify a port on the switch, and that's the only port allowed to inject router advertisements into the network. This is like Cisco's sticky ports and other solutions they've had. Now, the problem with that is it is trivial to bypass, and Mark Hauser, the guy at Chaos Communication Congress that wrote this tool I've been using, this Flood Router 6, has already bypassed it. All you have to do is fragment your router advertisement packets into 2 packets, and it'll sail right past router RA guard. So this is, of course, always the case. Web application firewalls and anything, you have an attack. The first layer of defense is like pick a fence. There's a little bit of an obstacle that stops this particular attack tool, but the slightest variation of the attack tool blasts right through it. So the defenses need to get better, but at least there are some defenses for what they're worth. All right. So if you want any of this stuff, it's all at samsclass.info, videos and such, and instructions how to do all these attacks. Especially that Slackware one, you really need the instructions. That took me weeks. I kept trying to give up. This black hat kept laughing at me on Twitter. God, you're too stupid to make it work. It really works, man. I just took down another server. Well, he motivated me. I appreciate it. You know. Any questions about anything? All right. Well, I guess that's it. Farewell. Oh, the only Android phone I have is an old HTC, the very first one, I think.
I have yet to find an Android phone that actually you can get to the IPv6 stack on.
Yes, the Android phone, I think, and also the iPad have the delightful property, you can tell that it is automatically configuring IPv6 addresses from the outside, but you can't find them on the inside. Which is true of a lot of devices. A lot of devices have IPv6, but they don't really know it. You know, you can't really use it, but it is there. But yeah, you can tell, like what I was doing here, I can send out the packets and I can tell if somebody listened, even if there's no way inside that operating system to see it. Which means they are using some components of software and hardware that are in fact IPv6 capable, which is probably true of almost anybody these days. They just take some replaceable component and plug it in. I'll get out of the way. I think there's somebody else coming.